Welcome to this educational video on Introduction to Biostatistics. In this chapter, we will explore the essential role biostatistics plays in public health, medical research, and population science. This content is based on Essentials of Biostatistics in Public Health by Lisa M. Sullivan. By the end of this chapter, you'll be able to do the following. First, you'll be able to define what biostatistical applications are and describe their objectives. Second, you'll understand the limitations of biostatistical analysis, including why results from samples may vary. Third, you'll be able to compare and contrast a population and a sample, and explain why sampling is so important in public health research. Fourth, you'll explain the value of random sampling and why it improves the validity of a study. Finally, you'll be able to develop research questions and identify outcome variables that help solve important public health problems. These goals will help build your foundation for understanding biostatistics in action. First is, what is biostatistics? Biostatistics is defined as the application of statistical principles to the fields of public health, medicine, and biology. These principles include collecting data, summarizing results, analyzing patterns, and making informed conclusions. Biostatistics helps us deal with uncertainty, variability, and complexity when studying health and disease. It allows public health professionals to make evidence-based decisions that affect entire populations. Consider this example. Cardiovascular disease is the leading cause of death in the United States. More than 2,600 Americans die from it every day. Researchers use biostatistical tools to estimate how common the disease is, identify risk factors, and evaluate treatment effectiveness. Second is, why samples matter. In an ideal world, we could study an entire population. But in reality, that's not possible. Instead, we study samples, smaller, manageable groups, and use them to draw conclusions about the broader population. This is the essence of statistical inference. If the sample is carefully selected, the results can accurately reflect the truth about the population. For example, if we want to know how many adults in the US have cardiovascular disease, we don't test all 300 million people. We test a sample and make an estimate. The key is making sure the sample is representative. Third is, what are the issues in biostatistical research? Using biostatistics responsibly means addressing several key issues. These include clearly defining the research question, choosing the correct study design, ensuring the sample is representative and large enough, using the right analytical tools, quantifying uncertainty accurately, avoiding overgeneralization. We must also be able to explain how variables relate to each other and apply findings only to the appropriate population. These are not just technical concerns, they are ethical responsibilities. Fourth is making sense of contradictory results. Sometimes different studies on the same topic produce different results. One trial may show that a new drug is effective. Another might show the opposite. This can happen due to small sample sizes, poor study designs, or just random variability. Understanding how to interpret these results is a critical part of biostatistical thinking. Fifth is why this matters in public health. Biostatistics gives us the tools to interpret health data in ways that impact real lives. It helps us answer vital questions such as, what causes disease? Who is most at risk? What interventions work best? These answers shape public health policies, clinical guidelines, and community health programs. Sixth is, learning by doing. In this book, you'll learn not just the theory, but how to apply it. You'll explore examples from major research efforts like the Framingham Heart Study and various clinical trials. You'll also practice real computations, often by hand, to build confidence and skill. By the end of this course, you'll be better equipped to evaluate health research and contribute to evidence-based public health. Biostatistics is more than math. It is the foundation of evidence-based decision-making in public health. In this chapter, we introduced core ideas like statistical inference, study design, and population sampling. These are the building blocks you'll use throughout this course. Thanks for joining this introduction. Let's continue building your public health toolkit, one chapter at a time. This video content is based on Essentials of Biostatistics in Public Health by Lisa M. Sullivan.